Welcome everyone. Dobry dzień, Praha. And let me just turn on my personal computer. Okay, I think my Atari is ready. And now let's run the presentation. Hi everyone. My name is Kamil Borzym. I am a software engineer at Allegro in Poland. And today I will show you how to hack an iOS mobile app. What do I mean by hacking? I mean doing some activities that can be considered a criminal activity. So after this presentation you will know how to steal users' data on a large scale using a mobile app. And I don't encourage you, any one of you doing that. I just wanted to show you something that you all should be concerned about. So let's proceed. Let's see the plan for this presentation. So it will be simple. First, we are going to choose the app which we are going to hack. Then we are going to steal the user login, the user password. Then we're going to steal two-factor authentication code, and also we are going to steal some bank credentials. And that's the topic for today. So first, which app should we hack? And you know, I have an idea. I came here to this venue with my brand new DeLorean. I don't know if you know those cars, but they are gorgeous. The new version of the DeLorean runs on hydrogen. It has AI-powered autopilot, and it also has a mobile app. And I have this app here. It's like an MVP, so it looks like really simple, but I think we can use it for this presentation. After the first run of this application, I am requested to log in into the DeLorean cloud, and then I will be able to access my car. So let's log in. This whole app was created in SwiftUI, so the latest technologies. Okay, the app is super secure because I also need to provide SMS code. Okay, and you can see the dashboard of my car. The app is pretty simple. It's kind of MVP. What I can do now, I can click open, and now the car that is parked near the venue, it just did this with its doors, which would probably be a bit scary to people passing nearby, so let's better keep them closed. The app also shows me how much hydrogen do I have in the fuel tank. As you can see, I have 38%, and current range for hydrogen is 190 kilometers, which is not enough to get home. And obviously there are no many hydrogen gas stations in Europe, so DeLorean provides a really nice service. I could order the fuel, and the tanker car will came here in about 2 hours, will refuel my car, and I can do this just by a click. And then the payment is done with a pay-by-link payment method. I mean, this is a list of 10 biggest Czech banks. So I have an account in one of those banks. I will later on use it to log in into that account and pay for the fuel. So I think the app is perfect. It has Swift UI, it has WebView, it has everything we need. Let's go back to the presentation, and before we do a live demo, I need to talk a little about the theory. I can often hear people talking that there is really nothing to be stolen from users' devices, and that's only true when you think about a single app installation. Yeah, there is an access and refresh token inside the application when you logged in. And fortunately, there's no easy way of getting them without jailbreaking the device. So this is a single app installation, but I promised you to get the credentials on a large scale. So let's scale out this attack a bit. In reality, your mobile app is really kind of distributed system that runs on many instances, and each device of the app user is an instance that runs your application. And the app as a whole stores all the access and refresh tokens of all the devices. It's just a strange kind of storage when one device is used to store one access and one refresh token. And if someone gets control over the source code of this application, he or she can not only access the storage of all those devices, but can do a magic in the runtime and access all the runtime. So how can an evil adversary access the source code? Well, there are many possibilities. I will tell you about two examples. The first example, the frustrated employee. It's rather improbable because it's very risky. You know, we have a Git history, we have code review, and each line of code is being verified by someone, yes? Well, no. I can remember a situation in my daily job when one of my colleagues did something scary. This screen shows GitHub, but the issue is not about GitHub. It is about some other version control system. I only used the GitHub to show you the case that was a problem. So this pull request, it looks like it's just fixing the code formatting. There was something wrong, and someone probably used formatter or something. And this pull request was approved by two software engineers, and it almost landed in the main branch and got released. And my colleague, by accident, hid something at the very far right side of a very long line filled with spaces. So yeah, he didn't do this, which is, oh my God, you can see it. It's sending the password to the remote server. So no, he didn't do it. He did something different. But if he tried, he could sneak up this code snippet, which is logging user password to remote server. But being an adversary is rather improbable. Any of our colleagues in our project. The more probable way of attacking code is by taking control of one of external dependencies. Maybe some small library on GitHub. But is it an issue in real life? Yes. And I will just tell you about those two examples here. It's on the bottom of the slide, so I'm not sure if everyone can see those letters, but I will tell about them. First one is SolarWinds. SolarWinds is a name of company that provides network monitoring for US federal government. And yeah, they got hacked by third-party dependencies. So the whole US federal government was infiltrated by this kind of attack. The second one, probably more familiar for iOS engineers. It is about Xcode. When there's a new version of Xcode, everyone wants to download this new version. Also, people in China, and internet from China to US is pretty slow. And someone dropped a mirror on a Chinese forum and told everyone, just use it, you will download it really fast. And people started downloading that. And this Xcode has some addition. This addition made all the compiling apps also contain an addition that was sending a lot of stuff to remote server. So those apps were top-selling Chinese apps on App Store. To sum up, the adversary could either inject some code into the dependency source code or modified already compiled library. Did you know how easy it is to inject something into already compiled library? I will show you. Let's see. What do I have on my Atari? As you can see, we have static library, tinylib, and we also have some malicious code. First, we need to compile this malicious piece of code. And then we'll use AR utility. And it's done. And now this modified version of the library with some malicious addition can be just dropped in place of the original. If someone sends you a library using an email, for example, you could intercept the email and put your version of that library. But is it really a serious harm to have some malicious code inside such a library? Let's imagine this library is really small, nobody really uses that, it's only like a transitive dependency. Well, this doesn't matter, it will always be a problem, and I will explain you why. Let's have a look inside the application bundle of the My DeLorean app. Let's see what's inside. Let's see the files. As you can see, the application consists of main executable and many different dynamic libraries. And all this stuff runs as a single process. On iOS, as a developer, you cannot even start a separate process. The Unix fork instruction is blocked, so it will return -1 or something, and you cannot create another process on your own. And the process has one single large space of virtual memory. That means everything that is loaded in the application has some address in this giant space. The executable with all the code, with all the functions, is loaded at some address. Each allocated object is also stored somewhere there in this giant space. And what is important, each loaded library, like UIKit, like some unused library, is loaded on some address. That means you can access anything just by knowing the address. And to be honest, that is hard, because each time you start application, it basically randomizes those addresses, so you cannot guess them. But there is a very convenient feature in iOS runtime that allows to discover those addresses, and this feature is called Objective-C. So Objective-C runtime, during the application startup, searches for all the types, all the functions in the executable, and registers them in a central registry. And this registry is kind of a singleton. That means every piece of code in your process have access to that single runtime. You probably all use Swift. That doesn't matter. A lot of frameworks, system frameworks, still use Objective-C underneath. You probably use SwiftUI as well. It also doesn't matter, because SwiftUI underneath uses UIKit components a lot. So, for example, the text field component that I typed login and password, it uses UI text field, which is Objective-C based component. So it seems like with the right computer algorithm, I'm gonna hack that runtime. And if you wish to hack in your home later, you will need some additional equipment. And I brought some of those. I already lost my ATA cable. If someone finds it in the lobby, then please give it back. You will need a fast CPU. So you could use AMD, or you could use Intel 400 megahertz. It's also sufficient for the job which we are going to do. Also make sure you have at least 2 megabytes of RAM memory. I always carrying it with me in the pocket if I need additional RAM. So if you don't see all the code, don't worry. I will share that code on the floppy disk later. Please come to me with your MacBook, and I would allow you to copy that. But now, it's hacking time. So first, I'm going to import Objective-C. I'm also going to import UIKit and my exploits helpers written in Swift. I will provide interface for UI text field. This is a kind of extension for component in Objective-C. So malicious version of UI text field. Let's provide the alternative version of the initializer. So init with frame. Let's call it malicious one, because we are wrapping the original initializer. Let's call now the original initializer down there. It looks like a cycle, but we'll break it in a while. So we are wrapping the original one. So we are getting the UI text field. Let's add some callback. So the callback will be called malicious text field did change. So each time user types something into UI text field, this callback will be called. And let's use the helper that basically sends all the text to my server. Let's send the contents of UI text field. So now let's hook this callback here. And now we need to overload the load method that is called each time the application starts by the runtime. And I'm going to swizzle implementations of an initializer. I'm going to replace the original initializer init with frame on all the UI text fields with the malicious version. The code compiles. Now let's try to use it. So let's start netcat on localhost to intercept the network communication. And let's try to log in the SwiftUI app. And my top secret password. And also the SMS code. And we are in. Okay, as you can see, all the data, logins, passwords can be intercepted. And it's funny that even the two-factor authentication code can be intercepted before users accept that, which kind of bypasses the two-factor authentication. So the adversary can get access to all the user data provided in runtime in native components. But I think the most private data the user could see in the application, maybe one of the most private, is information about your bank account. So bank login, bank password, maybe your balance. So this kind of data can be briefly seen while paying with one of the pay-by-link payment methods. You just need to log in using your bank credentials. You need to accept the payment. And the whole process usually executes inside WebView. And today, iOS apps no longer use UI WebView. UI WebView back then behaved the same as a regular library. So when you loaded a web page into the UI WebView, the memory footprint was like getting larger. The whole page was stored in the memory space of the process. So in case the WebKit engine crashed, it happened a lot, then the whole app was crashing. And if you wanted to read the contents of the web page, so those login passwords from the WebKit, you could just access if you know the memory address, you could just access the memory location. You could dump the whole memory region, or even easier, you could just use the API because there was a method to access everything what's inside the UI WebView. And nowadays we use much safer alternative, which is WebKit WebView, and it comes from with the WebKit framework. So loading WebKit WebView doesn't increase memory footprint of your application. Why? Because there is a WebKit web content process inside the system libraries frameworks directory on all your iPhones. And its purpose is to run just the WebKit. So the DeLorean app has no direct access to the contents of the web page. It has no direct access to this web content daemon because it's a separate process. And the WebKit WebView communicates with the WebKit web content using XPC API. XPC is a low-level mechanism for bidirectional communication, and this is the macro kernel that dispatches all the messages between different processes. So WebKit WebView basically requests for web content to load some page, and the daemon loads the page and send it back in the format that allows to render it on user screen. So this time, if the WebKit engine crashes, just the service process is killed. After refresh, it will just restart, and you will again see the page, but the app will survive. So it looks like we are safe, or no, we're not. We can still inject arbitrary JavaScript code into the WebKit process. And this XPC pipe has a method which allows to just inject some additional JavaScript. So let's try to hack one more time. Let's write some JavaScript code. So again, it's hacking time. So let's again import Objective-C. Let's import UIKit and the WebKit. I'm going to also import my helpers, exploits written in Swift, and let's provide an extension in Objective-C for WebKit WebView, the malicious extension. We will provide the alternative version of the initializer as well. So let's use the default initializer and let's call it malicious one. Again, let's call the original implementation. It will look like a cycle now, but we'll break it with a swizzling. Let's return the original WebKit WebView. Now let's write some JavaScript in this NS string. So we'll get a document. We'll search for all the elements by tag name, and the tag name is body. We'll take the first one, and on each key being pressed, we'll call a function, anonymous function, and inside we'll just call an alert with a code of the key that was just pressed. Let's compile the JavaScript code using WebKit user script. So we'll create an instance of this. Injection time at the end of loading the document. And now we need to use the configuration that was passed as a parameter, and we're going to just inject the JavaScript into the WebView. We also need to read those alerts, so let's use the main thread for that. We'll dispatch on the main thread, and let's provide something called UI delegate. UI delegate is for getting the alerts from WebKit. We'll use my helper, and again let's overload the load method, which allows us to add code, add swizzling that will be run each time the application starts. And we are going to replace the initializer with the malicious version of that initializer. The code compiles. Let's run the netcat, and let's go back to my DeLorean app. As you can see, the first exploit still works. Let's log in. And now, let's buy some fuel. I have an account in Zlaty Kruh Bank. I don't know if you know that bank. It's probably the largest bank in Czech. I will use my credentials to log in, and then I will confirm the payment. And I'm very happy because in about 2 hours I will have my car ready to hit the road. Okay, I will stay for the after party, but after that I will have car full of hydrogen. And some of you are probably happy because you just learned the credentials to my bank account. So please don't use it. I have a young kid here in the first row, and I have to buy food and stuff like that. So please. Is there any hope for web? Well, there is something called Safari View Controller. It shows a promising direction, but it requires hacks to fully support interoperability with the native app. Let's understand why this Safari View Controller is safer in this code injection scenario. Safari View Controller uses something called Safari View Service. It's yet additional application on all your iPhones that is used by Safari View Controller to load a page. So additional, like a layer in the middle. How does it work? Well, the app requests the Safari View Controller to load a page. Safari View Controller using XPC API will request Safari View Service to load a page. Safari View Service will run WebKit. WebKit will request WebKit web content to load a page. So JavaScript injection is still possible here, but Safari View Controller has no methods to inject JavaScript. Also, I've been trying for some time to decompile it and check if there is in Safari View Service any method that allows to inject JavaScript code. I haven't found that. I think we can assume there is no such a method. So this Safari View Controller, it is based on _ remote view controller. So this kind of internal view controller is been used for a couple of iOS versions. And it basically allows to display view controller that runs in a totally separate process. So Safari View Controller is not the only view controller using that. There are many other, like Photo Picker, Contact Picker, Make Composer. If you tried to access something inside the Contact Picker, you would see nothing because it's not really in your process. iOS just fools you to think that it's yet another view controller in your application, but it is not. All those view controllers are really safe because they run in a totally different process and they don't allow memory access. Time to wrap up. Web has iframes, and iframes are protected against the access from the external scope. macOS have custom XPC services, so you can attach an executable to macOS application that will run alongside the application. You could probably keep this application small, you could audit it better, you could feel it's safer to put some critical code in that additional XPC service. As for iOS, each iOS application has a single memory space. So every element is accessible in runtime for any other elements in the same app. Now I will show you the slide that is the most important thing from this presentation. Any iOS application has full access to the runtime of any secure third-party library. And that works in opposite. Each library, even a small library from GitHub that you use in your project, it has access to the whole application. It has also access to all secure libraries like payment libraries and other stuff like that. And what should we do? The question is, what should we do now? To be honest, I don't know. But there is the brand new thing from Atari. It's called Atari GPT. And it works like a magic. I can write just anything on this keyboard, and it will give me the right answer. So let me ask Atari GPT, what should we do? Atari says we have multiple options. So first option, we could try to prevent malicious activity. Maybe we should ask library providers to not send them by email or also provide library hashes while downloading those libraries. Maybe we should verify all the lines of code during the code review. This option is not reliable because if you want to protect against someone, you need to think about all things around, and the person that is attacking only needs to find one hole to break all your security. So this option will not be fully reliable. Second option, we could try to detect malicious activity. We could monitor JavaScript injections. We could detect swizzling of system components. But this option is not fully reliable. Why? Because if you try to detect swizzling, someone might try to swizzle your detection mechanism. So yeah, you could try to detect if someone swizzles the detection mechanism, but the story will never end. It will be like the eternal war to break the application. And the only question is how much money and time does the person that is attacking have. So third option, we could try moving data-sensitive processes to Safari View Controller. This would be tricky, but probably would prevent anyone from accessing the contents directly. It would also badly affect user experience. It would probably not allow to create some beautiful SwiftUI animations as showed by Pavel in the morning, but maybe crease the tool from you that allows to render SwiftUI on web. Maybe will provide means to use the Safari View Controller to develop apps. I don't know. Let's see what the feature shows us. So can we do better? Option 4, separate processes. Imagine creating such an XPC, small XPC service running on remote view controller for logging to the application, for changing password, for payments, but it's currently not possible on iOS, maybe on the next WWDC. It's available for macOS apps, maybe someday for iOS. I think that, unfortunately, there is no single bullet for this issue. But the goal of this presentation was not to give you like solution, one golden solution. I just wanted to make you worry more after this presentation. And I think my goal was accomplished somehow. One final word, it's the end of presentation about my company, Allegro. It's a e-commerce company from Poland, and we recently joined forces with MOL here in Czechia, and you will probably see more Allegro in Czechia and all the countries to the south of Europe, which means maybe we'll see each other more often, I hope. So that's all. And where is the camera? There's the camera. If you are watching this presentation online, please remember to rewind the video to the beginning before closing the window. Thank you.
So thank you for this very modern talk. We have several questions and we have time to answer them. So let's start. Question number 1. Can you hack the Safari view controller to load a different URL?
Yes, you could like swizzle the initializer, and yeah, but so yeah, that is probably an issue, and someone could provide like alternative version of your page to load inside the Safari view controller. Then maybe you should try to detect what URL was used. Maybe you should use some heuristics in the web page to detect if the user that is logging in used the right page and prevent it somehow. Okay, I'm imagining like the new things, but yeah, the answer is it is possible, and yeah, someone could fool you that way. Providing alternative URL.
Thank you. An interesting financial question. Which way do you make more money, white or black hat hacking?
Actually, I'm not making money. It's my hobby that I'm doing in the night. And I'm a software engineer, so maybe I should try that.
Maybe talk to the person who suggested it. Okay, let's continue. If Safari view controller is running in Sandbox, will the request URL hack work at app side?
Safari view controller in Sandbox, that's request URL hack will work at the app side, and Safari will display. Yeah, that's I think that's the similar question that was asked as a first question. Yeah, someone could try to hack the URL and provide alternative version. So I didn't want to make you such worried about all the things, but I think some of you are really worried now, and you should.
All right. Is there a way to detect attempts to swizzle Objective-C runtime? Can we create some sort of whitelist and forbid all others?
Yes, you could try, like, the first method that comes to my mind is you can get the address of the function that you are calling and verify that function address is somewhere in the address space of an external library. You could compare pointers and verify, okay, initializer from WebKit WebView is actually inside the WebKit library, or it's not. Or maybe someone using some library for swizzling just swizzled the function that allows to get the address of the function and could fool you. You could try detecting if someone changed the method. Yeah, the story never ends. You could use some functions, but you can never be sure that those are correct ones.
And the last one, which music was used during hacking time? It was, I believe, at the bottom of the slides, but
Yeah,
maybe you can...
it was at the bottom. It's royalty free, so
Can we switch to the presentation, please? Yes.
it's called. I'm not typing. It's. Okay, we're seeing the video. I meant to show the slides, please. Okay, it's Carl Casey, White Bat Audio Hackers. It's on YouTube and Spotify, I think, and SoundCloud as well.
Perfect. Thank you so much. Don't forget to rate Kamil's talk on Slido. Thank you.
Thank
Applause.
you.